Hi everyone, this question is from CEE 2022 set B and question that is asked is from the topic trigonometry. It is asked the positive integer n greater than 3 satisfying the equation. This is the equation given to us and it has got 4 options. So you have to find the positive integer satisfying this equation. Okay, now to solve this question, so how to solve this? So first of all, let us write the question. So we have 1 by sine pi by n, which is equal to 1 by sine 2 pi by n plus 1 by sine 3 pi by n. Okay, so implies that first of all, let us take this term in the left hand side. Okay, why? For our simplicity. Now we'll get to know why we have done this. So sine pi by n minus 1 by sine 3 pi by n is equal to 1 by sine 2 pi by n. Okay, now let us take LCM. So if you take LCM, what we will get? Sine pi by n into sine 3 pi by n, right? So in the numerator you will be getting sine 3 pi by n minus sine pi by n, okay, which is equal to 1 by sine 2 pi by n. Now we know the formula of sine c minus sine d, so we can apply this formula here. So we know sine c minus sine d, which is equal to 2 cos c plus d by 2 into sine c minus d by 2. So we have to apply this formula here in the numerator. Okay, so it will break later on. So implies that what we can write here, so 2 cos c plus d by 2. So this one is c, this one is d. So c is what? 3 pi by n plus d is what? Pi by n divided by 2. Next term is sine. So sine c minus d by 2. That means 3 pi by n minus pi by n divided by 2. And the numerator we have sine pi by n and sine 3 pi by n, which is equal to 1 by sine 2 pi by n, right? So after that we can solve this further. So we are having here 2 cos. Now here take n as an LCM. So if you take n as an LCM, what you gonna get? We'll get in the numerator 3 pi plus pi, which will give us 4 pi, right? And sine, similarly here also take n as an LCM. So if you take n as an LCM, so we'll get in the numerator 3 pi minus pi, which will give us 2 pi, right, is equal to 1 by sine 2 pi by n, and the numerator we are having sine pi by n into sine 3 pi by n, which implies that what? 2 cos, here it is 4 pi by n divided by 2, which will give us 4 pi into divided by 2n into sine, here also same thing, 2 pi divided by 2n, and in the denominator we have sine pi by n into sine 3 pi by n, which is equal to 1 by sine 2 pi by n. Here if you clearly observed it clearly, that you can see 2 and 2 is getting cancelled out. Also here 2 and 2 into 2 is 4. So finally what we are getting here? We are getting sine pi by n into sine 3 pi by n, and the numerator we are having 2 cos 2 pi by n, and also here sine pi by n, which is equal to 1 by sine 2 pi by n. Now you can clearly see that sin pi by n and sin pi by n are getting cancelled out from numerator and denominator. So what you are having, 2 cos 2 pi by n divided by sin 3 pi by n, which is equal to 1 by sin 2 pi by n, right? Now cross multiply. So if you cross multiply, what you will get, 2 cos 2 pi by n into sin 2 pi by n is equal to sin 3 pi by n. Just cross multiply, right? Now we know the formula. Which formula? We know formula of sin 2 theta. Since sin 2 theta is 2 sin theta cos theta, so you can see we can apply this formula here, 2 sin theta cos theta. So we can write here sin 2 theta, right? So what we are getting here implies that sin 2 and theta is 2 pi by n, that means 2 pi by n is equal to sin 3 pi by n. After solving all this, what we are getting here is equal to sin 4 pi by n is equal to sin 3 pi by n, right? Now what to do now? We have learned previously the general solution formula. Okay, we know that if suppose we have sin x is equal to sin y, we can write the general solution of sin. General solution is given by what? Is given by x equal to n pi plus minus 1 to the power n into y. This we have learned before and this we know, right? So similar thing will apply here. Okay, so comparing this, you can write like this. Suppose this one is our x and this one is our y. So x equal to n pi minus 1 to the power y, right? So we can write here 4 pi by n is equal to n pi, right? So in place of n, because it will mix up with our question, because in question also we have n, so I'm writing p, right? So p pi plus minus 1 to the power p, and y is what? This one, 3 pi by n. So this is 3 pi by n, right? So after that you can do the simplifications and you can check whether the value for what value of n the given equation is satisfying, right? So first of all, let us check for odd. Suppose if p is equal to, suppose even 2k, okay, if p is an even number, then what type of solution we'll get? We'll have 4 pi by n is equal to 2k pi plus minus 1 to the power 2k into 3 pi by n, right? So implies that I can write here 4 pi by n is equal to 2k pi, and here minus 1 to the power 2k. That means it's an even number. So minus 1 to the power even number is 1. That means we'll have here plus sign. So plus 3 pi by n. So implies that what you can write, 4 pi by n minus 3 pi by n is equal to 2k pi, right? So we can write here, we can take n as an LCM and we will get here 4 pi minus 3 pi, which is equal to pi. So pi by n is equal to what? 2k into pi, right? Or 2 pi into k, whatever you like. So you can write here pi by n is equal to, we can write 2k as p, right? So pi by n is equal to p pi. So you can cancel out pi from both the sides. So we are getting p is equal to 1 by n. But we have assumed that p is an even number, but we are getting p is equal to 1 by n. That means it is not possible. Not possible. That means taking the value of p as even number, the answer is not coming, right? So let us take the value of p as odd. So if p is equal to 2k plus 1, let's see what is happening. So 2 pi by n, 4 pi by n is equal to 2k plus 1. That means in place of n I'll write p, and in place of p I'll write 2k plus 1, right? Pi plus minus 1 to the power n, right, according to our main formula. So here we have to write 2k plus 1. It is 2k plus 1 into what? Y. So y is what? 3 pi by n. That is here 3 pi by n, right? So let us solve this. So implies that we are having 4 pi by n, which is equal to 2k plus 1 into pi, here minus 1 to the power 2k plus 1. That means minus 1, the power of minus 1 is here odd. That means we will get here the answer is negative. So we will get here minus 1, right, into 3 pi by n. So implies that 4 pi by n is equal to 2k plus 1 into pi minus 3 pi by n, right? So what we can write here, 4 pi by n, this 3 pi by n will come in the left hand side, so we will be getting 3 pi by plus 3 pi by n is equal to 2k plus 1 into pi. Now what to do? So take another LCM, right? So we are getting 4 pi plus 3 pi, that is 7 pi, okay, and here is equal to 2k plus 1 into pi. So we can cancel out pi, isn't it? If we cancel out pi, what we are getting? We getting implies that 7 by n is equal to, this one is 2k plus 1, which we can write it as p. So we are getting p is equal to 7 by n. Now let us try to put the value of n given in our option, and let's see which one is giving us integer, right? So what options we have? We have 8. So if you put 8, that is 7 by 8 will not give us an integer value. Then let us put 6, right? So this 6 is also eliminated because 7 by 6 will not give us integer value. Let us put 5. No, it will not give us integer value. Now if you put 7, it will give us integer value. That means our answer is option D. Okay, thank you for listening.